I draw an F versus T graph, doesn't matter what the shape of it is. Let's make it something like this. 3 words should come to your mind. What are those 3 words? Area equals impulse, right. Area equals impulse every single time. Doesn't matter what we're asked. Okay, I don't even have a question up on the board here right now. I just have a graph. You have no idea what the question might be, but you still should think those 3 words right away. Area equals impulse. You're going to have to do that. You're going to have to find the area. Now, you may not be asked to find the impulse, but you're going to use the impulse, if you're not asked to find it, to get something else. Area equals impulse. So let's get the area of this graph, or at least let's look at how we would get the area of this graph. Let's break it up into 5 sections. Okay, section 1, section 2, section 3, 4, and 5. Sections 1, 3, and 4 are all triangles. We're going to find the area of those 3 triangles by doing what? Area is equal to 1/2 base times height. Good. Go ahead. Okay. Area 2 and area 5 are both rectangles. We're going to find the area of section 2 and section 5 by saying base times height because it's simply a rectangle. Now, a couple little things that I want you to pay attention to here, okay? First of all, sometimes we see an axis, particularly the x-axis, where the units are not seconds. Okay, we saw that in the example question that we did yesterday, where the x-axis is in milliseconds. Okay, that's really, really easy to miss. When you find the area, okay, pay attention to whether you've got seconds or milliseconds or newtons or kilonewtons or whatever. And if you don't have seconds and newtons, then get them. Get the area in our standard units. Okay, don't get the area in newtons and in milliseconds. Get the area in newtons and in seconds. That make sense? Okay, so notice that. Circle it or highlight it with your ugly highlighter. Okay, and then calculate the area in standard units. Now, the other thing that I want to draw to your attention is this. What's the difference between areas 4 and 5 versus areas 1, 2, and 3? Tristan? Good. We're going to make areas 4 and 5 negative areas. I guarantee you this. If you get a multiple choice question on an exam, and there's probably a pretty good chance that you will, involving a force versus time graph, and it looks like this, where you've got some above the x-axis and some below the x-axis. I guarantee you that, of course, one of the options is going to be this plus this plus this plus negative this plus negative this. That will be one of your options because that's the correct answer. But one of the other options will be this plus this plus this plus this plus this. Okay, and I guarantee you that some of you will pick that option, even though it's wrong. Some of you will pick that option. Don't be that person. Don't forget to subtract areas 4 and 5 from it because it's below the x-axis. Okay? If you get an overall negative area here, an overall negative impulse, what does that mean? I'm sorry? Well, it means, yeah, I guess it does. Actually, yeah, it's not kind of the way that I was thinking of it, but in the end, it's a loss of momentum. So that could mean a change in direction. Okay, not necessarily, but it could mean a change in direction. All right, we had 3 questions for homework, 2 on page 462 and 1 on worksheet number 2, question number 9. We're going to take a look at question number 2 here on 462, first of all. 2 says a soccer player heads the ball with an average net force of 21 newtons west for 0.12 seconds. Okay, here's force, here's time. It's a constant value of 21 newton seconds. 21 newtons for 0.12 seconds. Okay, there's my graph. What do you notice about this graph compared to the graph that I just drew? What's simpler about this graph? Matt? There's no change in what? Right, there's no change in the force. It's a constant force. Because it's a constant force, it actually allows me to use the equation F times T. Right? That works for a constant force. I'm not going to do that because I want to go with the same method that I always use no matter what the shape of the graph is. But I could technically in this case use that equation because it is a constant force. What are the 3 words that come to your mind as soon as you see that graph? Area equals impulse. We don't know what we're asked yet. We haven't read question B and C, but we know we're almost certainly going to have to find the area of this graph. Question B says, what's the impulse provided to the soccer ball? Sure enough, I'm going to have to find the area here. Now, the area in this one is pretty easy to find. It's base times height. It's 0.12 seconds times a height of 21 newtons. When we calculate that, we should get a number that is equal to 2.5. What would the units be for this? Not newtons per second. Newtons times seconds, right? Newton seconds. Now, when we look at the data that I have there, 0.12 seconds times 21 newtons, it looks like it should be 2.5 seconds newtons. Could I write that? Could I write seconds newtons? Sure, that'd be right. Is it also right to put newton seconds? Sure. Could I also put, if I wanted to, kilograms meters per second, even though you don't see kilograms and meters in the graph? Sure you could. Still a valid set of units, even if you don't see those in the graph. There's my area, there's my impulse. Now, question C says the impulse changes the velocity of the ball from 4 meters per second east to 2 meters per second to the west. What's the mass of the ball? We know that in question C, we're going to use that impulse equation, delta P is equal to m times delta V. Let's solve for m. We've got delta P. We don't have delta V, but we pretty much do. Okay, all you have to do is subtract those numbers to get delta V. Solve for m. Delta P is 2.5 newton seconds. Notice that by the way that we've drawn our graph here, we've defined west as positive. We may not have wrote that down at the beginning of the problem, but because of the way we've drawn our graph, says it's going to the west, we must mean that west is positive. Therefore, the impulse to the west is a positive value. Therefore, delta V would be 2.0 minus negative 4. Does that make sense? If west is positive, then the 2 meters per second has to be positive, and the 4 meters per second to the east must be negative. Okay, I could have drawn my graph so that it was below the x-axis and west was negative. I just thought it was a little bit easier to do it this way. Does that make sense? 2.5 divided by 6. 2.5 divided by 6, I believe it worked out to be, if I remember, 0.42. 0.42 kilograms. Any issues with that? No? Worksheet number 2, question number 9, the answer for the change in velocity was 5 meters per second. No issues with that either? Excellent.